Hello guys. So my name is Guilherme Blanco and I'm here to talk about how ORMs are not the responsible for killing your database, but developers or you are the responsible. So who am I? My name is Guilherme Blanco. I have a Twitter, GitHub. I work for a company named caramigo.com. We are competitors of AutoTrader, but we're more focused in I would say auction side of car dealing. So we sell cars and buy cars between dealerships. That's the focus between them. So we have a very extensive agenda. I hope I can fit in around 1 hour, but let's try. So here we're going to discuss today about dependency management, fetch modes, querying, caching, indexing, inheritance, cascades, and hydrators inside of Doctrine. But the general rule applies not only to Doctrine specific, but it applies to any kind of impedance mismatch implementation in object-oriented programming comparing to a database. So the first one is dependency management. For dependency management, we can start from a simple example like a blog and a component package, and each one of them have an association. Like a post contains a bunch of comments, and a comment is owned by a post. So whenever we're looking into a situation like this, and this happens on a daily basis when you're coding, like you're using whatever framework and you're dealing with packages, we have the situation that you have a bidirectional dependency between one package and another, and it seems pretty simple as this, but in reality, that's something that you do have between post knowing comments, comments knows about post. So your mapping would probably look something like this. So you have a post entity that contains a one-to-many to comments, and in the comment bundle, or the other package, the comment package, contains your property named post that you have a many-to-one post. So one post contains and many comments, and one comment contains only one post. That's a simple one-to-many, and the reverse side becomes a many-to-one association that we are used to create inside of Doctrine. I forgot to say about this, but this is not supposed to be a trivial, simple, for beginners levels talk about Doctrine. This is more like a higher, intermediate to higher level consideration. Experience with the Doctrine framework. So you have a situation like this, that you have posts, have comments, comments have one post. What you do have when looking at the package level, it's a bidirectional dependency between the blog and the comment packages. Whenever you have a cyclic dependency, so your combination of the arrows that navigate through the package diagram, it forms a circle. You have a situation that you cannot install a single package without installing everything else that contains as a dependency. I've seen this happens on every single company that I ever worked with. This is a very easy problem to have, and somehow it's very complex to fix. So you may have like a, let's say like a situation like this, or you may have something like you have an auction, in my case, that contains a bunch of reviews for the cars that get sold. The review bundle would know about the cars being sold, but the cars being sold doesn't know about the reviews that are being made because they are part of the separate package. So adding this dependency would generate an example similar to this one. So our idea is to eliminate the bidirectional dependency and have a unilateral dependency. So we would like to not have the dependency between the blog and the comment. Because if you consider in a real-life example, I may be able to have a blog post that does not support comments, but you may never be able to have a comment that does not have a post in considering a blogging platform. So one may exist without the other. So the blog may exist without a comment, but the comment may never exist without the blog. So in order to eliminate this, we need to remove the bidirectional dependency between the post and the comment. So in the post entity, we would not have any mapping related to the comment bundle. But in the comment bundle, we would have a mapping pointing to the blog post. I think that's a very simple example that I can formulate for you guys. By reducing the amount of bidirectional dependencies, you reduce the amount of entities that you have to navigate through the graph whenever you're persisting any kind of information inside a doctrine. So this is a very simple rule to thumb, but it's very powerful. People normally just don't pay attention to this, and they may enter on a huge graph full of dependencies that may slow down the entire application. So next topic is about fetch mode. The fetch mode is the ability that it can use the ORM to retrieve objects that are associated and how they can navigate through them. So basically, it gets supported for any kind of association, for collections and simple association mapping. So this is valid for one-to-one, one-to-many, many-to-one, and many-to-many, including self-reference associations. So how does this get mapped inside of Doctrine? So the first, you are able to point out your fetch mode, and then you are able to specify which is the mode type that you're trying to use. So by default, we have the lazy, which means it only gets triggered whenever you have the first operation. You have eager, and you have the extra lazy. So the eager is when an association, either a collection or an attribute, is fetched as soon as the owner of this association is loaded. So in the example of the blog and the blog post and comments, as soon as you load a comment, the blog post would be automatically loaded, even from the database if necessary. While in the lazy, the association is only fetched when the application invokes an operation over it. So basically, you're fetching the comment, you're not loading the blog post until you actually use it for the first time. And extra lazy, it's individual access elements that exist inside of the association or the attribute. It's going to be loaded whenever it's needed, but they're going to not fetch everything unless it's absolutely necessary. So one possible example is if I expand the blog post and the comment example is, in a post, I may be able to define an author as a fetch mode of eager. So this means that whenever I'm fetching a post, I'm always fetching the author, the user entity attached to the blog post. This means that behind the scenes, Doctrine is going to make us a left join or an inner join, depending if the column is nullable or not, and whenever possible. If you're dealing with an inverse side, it's going to build as a separate query for you. So the second one, which is the lazy, is what we could potentially do with comment and post. So you're mapping a one-to-many, and then you're telling that you have a fetch mode of type lazy. So nothing's going to happen, and the post is going to be a proxy until you need some information over it, like grabbing the title, or grabbing what's the author, grabbing the tag list. Then that's when the blog post is going to get loaded, and together with the loading of the blog post, the author is going to already be loaded. So why? Because you have a deadly sin over the eager. fetch mode. Now, whenever you're discussing about planning as an eager or planning a lazy or extra lazy, you have to carefully think how your application is going to behave and when you're going to use each one of the types of your association, each one of the data that you have about your association. So if you're dealing with the case of a user that contains a bunch of addresses, and you're going to always, absolutely always, return the address whenever you fetch a user, that may be a valid information. Now, when you think that you have the user and you have the example at the top of it, like the blog post, which contains the author, which is also the user, remember that you're not only loading the user, you're also loading the address as part of the same database call. So you may enter in a spider of cascade loading because you have set up everything as an eager. Now, when we're dealing with the extra lazy fetch mode, we're basically talking about, this is more like valid for collections that I would say. Whenever you have to do a count, for example, you don't need to load all the tags that you have bound to a blog post. You could just make a select count. So this means that you don't necessarily need to load or initialize all your collection when there's not an absolutely need to do it. So if you are making a slice because you want to make a pagination over the tag list, you could just apply a query with the limit and offset. You don't have to load everything in order to actually return to you. So let's say that I'm talking about a Facebook example that they have a post inside of the newsfeed. So they display the amount of shares or likes that you may have. But that's just the number. You don't have to load everybody until the user actually clicks on the amount of likes, and then you're going to display only the X amount. So you basically just need a count. And to apply only the count, you don't need to load everything, and which can potentially consume a lot of resources and put your database down. You can just return the count. And to only return the count, without loading or initializing the collection, you can do this using an extra lazy. So I think I made myself self-explanatory this fetch modes. But if you guys have any kind of doubt or want to ask anything, we're going to have a comment later that we're going to filter, and I'm going to be able to explain to all of you guys. So the next topic that we can discuss is about how you're going to query the information, how you're going to return the information from the database back to your application. We discussed that the fetch modes already provide you some level of automatically joining data and returning as part of the same query. But the query itself can actually enter in a situation that you're loading things without even noticing. So in that example that I discussed, that I showed about the blog post that contains a tag list, because it became a extra lazy, you may be wondering that if I just return the blog post and I'm displaying like the title and traversing through the tag list, what would happen? Well, the extra lazy does not load until it's absolutely necessary. So what's going to happen is, in the situation that you're selecting only the blog post, returning the result, and then traversing through every single post and getting the tag name for each one of the tags that exist for one post, you are entering an n+1 situation. Now, the n+1 situation happens because you are deferring the load of the collection to the very end. But your very end only happens when you're iterating through every single blog post, which means you're executing one query whenever you're hitting the get tag list in this example. So this means that you're going to execute the n posts plus one query that actually loads the post. This is a very non-problem in ORMs, and they're very easily solved whenever you do joining. So if the language is the DSL, or the query language that the ORM supports, allows you to join over associations, this problem is easily solvable. So in Doctrine, we have the joining support. So we have left join, inner join, that simplifies the workload for you. So by selecting this information and automatically left joining the tag list, you would not happen the n+1 anymore, because you would already load the information whenever you're returning it. Now, one thing to keep in mind, and this normally I don't write on any of my slides, but it's something that you have to remember for life, is that whenever you're building your query and you're joining two collections at the same time, behind the scenes, what you're doing, you're building a Cartesian product of the result set that you return from PDO. So let's suppose that I have the tag list and I also have a category list. So you would have the product of all the tags of a given post multiplied by all the categories that you have for that same post. So you may be returning 500 rows representing a single post. So a good rule to thumb is whenever you're handling a massive query that needs to join more than one collection, separate in two queries, because you are reducing the amount of rows that you're returning from the database in order to actually happily return to the user. So we had an example in the previous company that I was working with, that we have the users were returning friendships and we're also returning other information related to them. And if we're decoupling in two queries, the first result would only return 520 rows, and the second one would return 11,000 rows. The problem is that they made a Cartesian product between the two, which made them return almost 5 million rows. So that was terrible, and it was blowing away the database, because they were returning every single thing that they had as a Cartesian product. So returning 5 million rows, while in reality the maximum that you wanted was purely 11,000. Well, that's a good way of optimizing. So not always joining information is the optimization point. So sometimes segregating a single query into multiple queries may actually solve a problem that's hidden from you. So now this is something that you can actually do whenever you're querying with DQL. So you can join, and the DQL itself is a very powerful DSL. So when I mention as DSL, it's a domain-specific language. So DQL is actually it's really a compiler that happens behind the scenes. So I wrote the DQL from beginning to end, and one of the key ideas from the DQL is that it could be parsed as it was a language, a programming language. So I built a grammar around the DQL. So this grammar is a very big grammar. It's as big as the PHP one. It's even bigger than the Java one, to be honest. And it's able to do a lot of stuff for you. So the I wrote the EBNF grammar, extended Bacchus and normal form, which is basically all this. So it's a very big grammar that provides you almost the same thing that you can do with SQL, general SQL. Now, whenever it's not supported, we can somehow adapt the DQL to do the same work for us. Now, just as an example on how powerful the DQL can be, I can actually give you guys a real-world example. So I mentioned before about the Facebook activity wall. So here's a sample query using DQL that can expose the exact same information as a newsfeed. So it's only one DQL query, that's based on Facebook activity wall entries, and you're able to filter by the entries that you wrote. You're able to filter by the entries, the entry that was on your wall. So if you are a subscriber to anyone else, if the user is your friend and your friendship is approved and the subscription is not even muted from the other side, and if you're a part of the group that you do participate, like an event or a generic page that you create inside of Facebook. So this is a simple query. Well, not so simple, but this is a query that can expose to you how powerful the DQL can be. So here we're making a select join with 2 inner joins, 1 left join. You're using subqueries, 2 subqueries to be honest, using ORs and cases as nested queries to do everything that you need. So all I can tell you guys is that DQL is powerful, and if you guys find something that's not powerful enough, you guys can message me, and I can build the support for that. So the next topic is about caching. So I can explain as much as I can from the caching perspective, but there's a limit of what the ORM can do for you and what is up to your application to do. So Doctrine by default supports 4 levels of caching. The first one is called metadata caching, which is basically the cache mapping of entities. How when you map using XML, YAML, or even annotations, how it's going to cache this information to not be able to parse the mapping file over and over again. So you only map it once, generate a cache file, and reuse the cache file over and over again. So if you guys use like Zen Framework or Symfony, they do have the caching already built in for you guys, which I think it's APC by default. Now, if you guys are using PHP 5.5 and plus, which you guys should, you have to install APCU to do the work for you. But you are more than happy to use anything else like Redis or Xcache or Zen Data Cache, whatever. Now, the next type of the cache is the query cache. This one basically caches the parsing and walking, so the compilation between the DQL language and the SQL language. So whenever you're building a parser, which is basically what the DQL is, you're reading into the language that was mapped, which is DQL, and it's always transpiling into another language, which in this case is SQL. So it's the same thing if you write like a C program. You're writing C, it's reading the C, and it's generating you binary code. So basically the query cache is nothing different than a cache that stores the conversion between your DQL query and the output of the DQL query into SQL. So this takes into consideration all the parameters, all the type hints, everything that you have defined at the top of the DQL. That's what it takes into consideration. The third one, it's a very special kind because it's heavily affected by the fourth one, which I'm gonna not discuss about what it is in this talk, because I may spend a day explaining what the second level cache is. But the result cache is the cache that returns from the SQL into the result set. So whenever you're executing the query, your result may be stored as a table itself. So your result table is the one that gets stored as part of the result cache. So whenever you have the query cache and the result cache properly stored inside of your cache storage, you may be able to use, for example, APC into the query cache. So you have your DQL to SQL conversion, then you have your SQL to the result set conversion into another cache layer, for example, Redis. So let's say that I have the example that I'm always fetching countries from the database. So whenever I have the user, which is from a specific country, you may be able to only return, never query the database, because you have your DQL to SQL conversion already stored inside of APC, and then your SQL to the result set for that country is already stored inside of your result cache. So you are returning the information purely for the hydrators. Then the hydrators would load your entity for you. Now, everything changes when you use the second level cache. So all I can tell you guys is that that's complicated. So it's a new feature that came out in the Doctrine 2.5, but it drastically changes the way that we store the results. So as a quick explanation, the result cache allows you to store individual results as individual entries inside your cache storage, and your result set, your PDO result set, becomes only pointers to the other cache results, to the individual cache results. So whenever you're loading the information, you load the list of pointers, and then you load the results as individual records. This heavily simplifies the way that they do a find, or find by ID, or find by name, because the list is going to be only one. So your ability to load potential stale data is minimized. So I can explain in a better way of second level cache if anyone have more doubts later. So here's an example of how you can use the result cache. So you're basically building a query, a regular Doctrine query, DQL query, selecting all posts, and you want to make this is a result that you're going to store for 600 seconds, which means an hour. No, sorry, 10 minutes. So you're using the same result, the PDO result set, cached for 10 minutes. And you're always returning this from the cache storage. So after 10 minutes, the cache is going to be expired, and then you're going to load it again from the database. So in this situation, the first call is going to load the information from the database. The subsequent calls in the next 10 minutes is going to only load the information from the cache storage. Now, the next topic is, because Doctrine always controls your database for you, we have the ability to sometimes to configure, and we want to configure indexes to simplify and speed up lookups. So by Doctrine being able to stay and controlling your database, people will start to wonder how you can create indexes that control specific table instances. So one way is that Doctrine hints the schema tool to generate indexes over specific table columns. So one way of doing this is by expanding the ORM table definition and providing either unique constraints or indexes, or purely indexes over that table. So I gave here as a simple example one unique index telling that the username must be unique for the given blog post application, and I have another index that works at the top of the name and the password for login. So these behind the scenes, the unique constraint and the ORM index, they work behind the scenes, telling the database, in the case of the unique constraint, to generate a unique index over the table users of the column name. And the name of the constraint is the name that we're going to offer for the unique index. So the same thing happens to the index whenever you're defining it. So the name of the index is preserved whenever you are creating an index in the database. Now, you are able to specify any kind of name as part of your index or the unique constraint. But the problem is that some of the database drivers that Doctrine do support, they only accept up to 32 characters in the index name. So whenever you type a name that's over 32 characters, this is going to be turned into a hash. And then you may never be able to figure out what's the index for. So you better choose wisely what's your index name. So inheritance is another very tricky area inside of Doctrine, or not only Doctrine, but any ORM, because each one of the inheritance have some good side and bad side. So it's a very deep topic, and each one of the inheritance types that exist today, that's none or exposed to the users, have some advantage or disadvantage. The first one that we are going to discuss is called concrete table inheritance, which is also known as one class, one table. The second one is called the single table inheritance, which means you may have multiple classes and only one table. And the last one is called the class table inheritance, whenever you have multiple classes that maps into multiple tables. So the first one is not fully supported by Doctrine because it makes absolutely no sense, and we're going to never support that. So we do mask the support for the user by providing some of the support of the concrete table inheritance. So when I say that we support some pieces, is because we have the concrete table inheritance as a mapping, as a map superclass. I'm going to explain this later, but I'm going to just try to explain a little bit now. So whenever you're trying to build an inheritance that tries to use the concrete table inheritance, so we're discussing about inheritance. So we have three types of inheritance: concrete table inheritance, single table inheritance, and class table inheritance. Now each one have their own types. So concrete table inheritance is a type that I was mentioning when the screen went up, is that we didn't want to support fully, basically because it makes no sense. So the idea behind the concrete table inheritance is that every single node, every single entity that you are able to store information, which means it's not an abstract class, it would have their own table. So we made this to be easy to be supported. However, the part that we also have inside of the concrete table inheritance, which means fetching the information and playing with the information, we decided to give up. It doesn't make any sense because the only way to support this operation is by having unions. So you select from one table, union, select from the other table, union, select from the third table, in the case that you have three. So it doesn't make sense because as soon as you have more than two elements, two tables in the inheritance, you're fucked. So sorry for the bad wording, but that's what you have. So because it doesn't make any sense, we just didn't want to support this. So we made the basic support, which is the ability to create an abstract class and offer the properties to the users. That's called map superclass. So just as trying to explain the issues that you have behind the scenes inside the concrete table inheritance is that for the advantage is that you never have the lock-in problem when you're trying to fetch one specific information of one specific type. So you never have waste of space. So you never have irrelevant columns. However, on a disadvantage side, it's not difficult. It's almost impossible to deal with primary keys. How are you able? It's basically impossible to handle in the case that you're inserting one user, now you're inserting an admin, now you're inserting a publisher, now you're inserting an editor, and you need to be an auto-incremented primary key. And if each one of them are in their separate table, you can't have primary tables unless you use only one sequence, which not all the drivers support, and sharing the sequence between all the tables. So it's difficult, not impossible. So you already have to choose your database based on that you plan to do the support ahead of the time. Now, searching on the user class, for example, means that you're searching on all tables, which means you're selecting everything from admin, selecting everything from publisher, selecting everything from editor, selecting everything from user. So it's not good. So that's why we gave up, don't support. Let's make life from all the users better. And whenever you're changing a column, so I'm updating, for example, we have a case like you're dealing with a MySQL 5.5 database, and now you need date time to one specific date time to support milliseconds, which they don't. So then you're gonna have to modify all tables in the hierarchy to update the created column. So you're gonna have a lot of trouble. You're gonna probably put all these tables into locking state, and you're gonna have to enter maintenance mode for whatever time is needed until the update, so the change in the data definition, finishes. So you may put your entire system down for 16 hours, for example. So here's the way that Doctrine supports sharing columns and associations between different classes. So here we have a class person that I map the first name and the last name, and they are both string columns. And then on the user entity, which extends the person entity, you're gonna inherit the properties defined inside a person. And then you're gonna be able to map your own ID identifier with generated value with your column as an integer. So at the end, whenever you're creating the table, you are going to have your ID with the first name, last name, and setting your primary key. So this is an example in MySQL. Now, the single table inheritance, it's very good because you only have one table to fetch the information inside the hierarchy. Now, the other thing is that you don't have to use any kind of joins because all the information for the entire hierarchy, all the columns are inside of a single table. And refactoring the fields between the hierarchy means that you're not changing the database table. So you never have to add a column or delete a column. However, you're going to waste space in the database unless you're using Oracle. If you're using Oracle, you're not wasting space. But if not, you are wasting a lot of bytes in your storage. Also, you may enter in a lot of logs if you're selecting many things or if you're updating many things. Remember that in the case of MySQL, if you use more than 70% of the table, if you're trying to select for an operation more than 70% of the table, you are putting the entire table into lock mode, which means you're not able to modify data anymore. So also, you're unable to define a property with the same name in two different classes because this is going to collide in the database table that you're creating as part of the inheritance. So to map it as single table inheritance, we need a specific column for that. So we normally name this column as discriminator column. So discriminator column is one column that exists in the database table and it's not accessible by any way for you in the ORM. So it's used purely internal that uses to map one string into the class that needs to load. So basically, here I define a discriminator column which is of type string, and then I mapped two elements. So the user, which points to the MyApp entity user, and I have the second one, which is employee, which maps to MyApp entity employee. So whenever you're trying to fetch information, you're going to use this column to figure out which class you have to load. So in which object entity you're going to result. And to extend it, so to map as a subclass, so the class employee, you basically just extend the user. So the other problem that you have here is because the inheritance needs to be mapped at the root level, which in this case is user, you may enter in a situation that the user, so the package that contains the user, falling back to the first section that we discussed, which was the dependency management, we may enter in a situation that the base class should not know about the children. So under these circumstances, and well, to be honest, for any circumstance, do not use inheritance. Use composition. That's going to be easier for you, and it's going to make your life happy. So you're going to not have to wake up on a Friday night or a Sunday midnight to fix a problem because your table is in lock mode. So just saying. So here's the explanation of inheritance, just don't use it. So whenever you have the inheritance, single table inheritance, you are going to enter in the situation that all the columns, it doesn't matter which one you have defined, it's going to be part of only one database table. So here you have ID, first name, last name, the discriminator column itself, and the columns that exist on any other object, like row, that exists inside of employee. Now, when we talk about the class table inheritance, this means that every single piece, every single class that contains an information is going to have a class and is going to have a database table that represents the same information. So the pros is that it's very easy to understand. And also, the database space is optimized because you have a database table that's normalized. So you also have a direct relationship between your domain model and your database. However, you may enter in a situation that you have to join a lot of stuff in order to fetch the information. So because you have a lot of join, it may be very slow. So also, whenever you have to refactor the field, so I'm moving a field that used to exist inside of employee, like row, and moving to the person, this means that you have to update the schema. And you may enter again in the same situation as the concrete table inheritance, that you may put your entire system down to a scheduled maintenance. And also, if the superclass table is accessed a lot, you may enter into lock mode because multiple queries may be trying to fetch the information at the same time, and it's in the base table, so 70% locked. And to map, the only difference that you have is the inheritance type. So the ORM inheritance type, that's what you have is difference from the single table inheritance. The single table inheritance, you have inheritance type of single table, and in the class table inheritance, you have a type joined. Everything else in mapping remains the same. So whenever you're creating this as a database table, you create one table that represents the user with the ID, first name, last name, and the discriminator column, and then your other object, which is the employee, is going to have the ID and the row. However, this ID in the employees table is going to be a constraint, and we're going to have a constraint that maps the foreign key to the user's key, and it also contains the on-delete cascade. So what I'm trying to say, do not use the inheritance, I have a reason. So the reason is that sometimes when you're mapping data around and you're trying to load this data, so the hydration part of the ORM gets messed up. But the problem is not an ORM specific. The problem is how object-oriented model behave. So let's suppose that I have a one-to-one or an inverse one-to-one. So let's say that my blog post in the beginning, I said that there was an author. Let's say that this author represents a user with an inheritance, which is the second example. Whenever you're loading the blog post, you have to figure out what's the class at the other side to either hydrate in the case of a fetch eager, or to generate a proxy. So it doesn't matter which kind of thing, eager or extra lazy, you always have to load in order to fetch the information. So because you have a lot of join, it may be very slow. So also, whenever you have to refactor the field, so I'm moving a field that used to exist instead of employee, like row, and moving to the person, this means that you have to update the schema. And you may enter again the same situation as the concrete table inheritance, that you may put your entire system down to a scheduled maintenance. And also, if the superclass table is accessed a lot, you may enter into lock mode, because multiple queries may be trying to fetch the information at the same time, and it's in the base table, so 70% locked. And to map, the only difference that you have is the inheritance type. So the ORM inheritance type, that's what you have as difference from the single table inheritance. The single table inheritance, you have the inheritance type of single table, and in the class table inheritance, you have a type joined. Everything else in mapping remains the same. So whenever you're creating this as a database table, you create one table that represents the user with the ID, first name, last name, and the discriminator column, and then your other object, which is the employee, is going to have the ID and the row. However, this ID in the employees table is going to be a constraint, and we're going to have a constraint that maps the foreign key to the user's key, and it also contains the on-delete cascade. So what I'm trying to say, do not use the inheritance, I have a reason. So the reason is that sometimes when you're mapping data around and you're trying to load this data, so the hydration part of the ORM gets messed up. But the problem is not an ORM specific. The problem is how object-oriented model behave. So let's suppose that I have a one-to-one or an inverse one-to-one. So let's say that my blog post in the beginning, I said that there was an author. Let's say that this author represents a user with an inheritance, which is the second example. Whenever you're loading the blog post, you have to figure out what's the class at the other side to either hydrate, in the case of a fetch eager, or to generate a proxy. So it doesn't matter which kind of thing, eager or extra lazy, you always have to load this information, because you can't distinguish if this is going to be a user or if this is going to be an employee instance. So you have to load the information in order to figure out what's the class that you're going to build a proxy with, or what's the class that you need to instantiate. So even though you have defined as an extra lazy, if this is part of inheritance, it's not respected because you have to load it. You don't know what you have on the other side. The same thing also happens when you're deferring the eager load when you're querying. So whenever you're querying information and you may have a hint that you say, do not eager load, it may not respect you and may say, okay, I'm going to still load it. So I don't know if I make myself very explanatory, very simple to understand. But whenever you have an association and the other side contains an inheritance, you cannot just not load the information. You have to load the information because you have to know which object instance you have to instantiate the object. That's why, even though you have mapped and not been trying to load, you may enter in an n+1 problem because the other side, you never know what's going on. Now, the next topic is about cascades. So the cascades also operates at the top of the associations, and it's a hint for the unit of work on how it should operate at the top of the associations when it contains a graph change. So when I mean as a graph change, whenever you are inserting, deleting, updating information, it checks how deep the unit of work is going to traverse for changes inside of your entity graph to figure out for changes. Now, this is not the same as the change tracking policy, which I'm not discussing here because that's another very lengthy topic, but it works pretty similar in the way of how it inspects for the operations or changes that happens inside of your entities. So my general advice is use it there in a very careful way. It's powerful, but at the same time, you may be shooting yourself in the foot. So if you map everything using cascades, you're increasing the graph, the amount of nodes that needs to navigate to check for a possible change set change. So when the compute change set algorithm inside of the unit of work is running, you have to detect for all the edges. And then this may take a long time. And when I mean a long time, it's a longer time to persist, delete, merge, detach, or even refresh an entity. So in the case that I have the user in comments that you do have altered, so this is a bidirectional one-to-many on inverse side, for example. So you have the ability to persist and remove whenever you're changing something in the user. So whenever you're changing something into the user, you're also cascading to introspect for changes inside of the comments that this user have made. Or whenever you're deleting the user, you also may delete the comments that this author have made. So my general advice is, normally I tell people to not use it until you face a situation that you have to enable it. It's the same thing that I tell people when they are coding a class, and I say, like, should this be a public, protected, or private method? I say, always start with private until you can prove me wrong. Then you increase to protected, and then you're going to increase to public. So cascade is the same thing. Always start without anything mapped, and then you add it as needed. So the last topic is about hydrators. So this is the bottleneck of any framework, any ORM framework. And the problem is that you cannot easily solve. But there's ways to circumvent the hydration process. So the hydration process is whenever you're using a flat structure, like a PDO result set, it's a table of results, and you're creating an entity graph. You're creating a series of objects, reusing instances whenever you have duplicated information, so you always have the same instance. So this is a very costly operation, and we've been trying to minimize the time consumed inside Doctrine by all the releases. I've made a bunch of updates inside the hydrators for the version 2.5. We managed to get a 20% performance increase, but still it's a very expensive process. So whenever you're using hydrating entities, instead of hydrating purely the entities all the time, you may want to hydrate the entities only when you really need to operate at the top of these entities. Otherwise, you can use other type of hydration to do that may actually fulfill your needs in a better shape. So, for example, if your purely uses is to actually modify, insert, update information, so you may actually just get the result, and then you're going to have your entity graph. But if you're purely returning the result because you want to display on your screen, you may not need to actually enter all the object generation inside of PHP, which is a very expensive process, not only for the doctrine itself, also for PHP. They have fixed this problem in PHP 7. It's much better, but still, it's a very costly operation. So in the case that you're dealing only with fetching the information to display, you may not want to have the objects. You may be able to fulfill your needs by only returning the array representation of these objects. So in this case, you can use the array result. So this is going to agglomerate all the fields together as if it was columns, but it's going to return to you as an array structure instead of object structure. So this is my recommended way to operate, unless you really need to manipulate the object somehow. So like using in a persisting operation. Now, whenever you're returning a list of IDs, for example, or you're returning single column operations, you may be able to use a scalar result. You don't need to try to create objects that is going to generate proxies for each one of the entity instances. You may only return an array with only one column of a bunch of values. In this case, you use the get scalar result that's going to offer you everything that you need. Now, if you have to do an operation, that's going to be a very costly operation. So you may enter in a situation that you're traversing all the users to execute one specific operation in the background, for example. Instead of trying to load all the users into memory and then processing each one of them, a good approach is to either you're going to fetch in batches, like every 100 users you're going to process and then you get the next batch, or you can build an iterator and traverse through this PDO result set using the iterable result. The iterable result operates at the top of only one entity, no joins. If you do the join, it's going to get messed up. Now, if you're returning only one object and you're never dealing with multiple objects that you're going to return, you may be able to do a get simple object, which is going to only hydrate one result. Now, if you're returning a count, for example, or you're returning a sum or only one column of only one row that you're returning, you may be able to get a single scalar result. Make sense? So that's pretty much it. If you guys have specific questions, I'm going to turn off the presentation now, so I'm going to be able to see you guys. I'm going to show myself, my face. Please, guys, don't get scared and run out of the room. I think that's going to be a very nice situation. I'm very comfortable seated in my basement, to be honest.
If anybody have any questions, you can kind of ask him here. My portable microphone and video. Although I don't need the video, I guess, unless he wants to see your face. Anybody want to ask any questions?
Hi. Thank you very much for presentation. I have a question from practical usage of Doctrine. And in projects where data becomes reasonably large, it's reasonable, but large tables and so on, the main showstopper in adopting Doctrine is one-to-one connection between entities in PHP and tables in MySQL, for example. And what's your best practices here? Because when you have this one-to-one connection, you essentially have to coordinate changes of your tables and PHP code. Whereas when you don't have one-to-one connections and mapping on a model level, you just can avoid this like very lengthy downtimes of site. Thank you.
Okay, you forgot to say your name.
Maxim.
So I need someone to mute. Okay, that's good. So now I don't need to hear myself. So I have some very large experience with PHP, being applying large projects. So in the previous company that I used to work for, don't laugh, but it used to be adult industry, and we we had a bunch of websites containing up to 86 million users. It was not Avid Life, it was not hacked, but we had to handle a very large volume of data. Now, when I mean a large volume of data, we're talking about 12,000 requests per second. So when you're dealing with this amount, your problem is not the doctrine itself. It starts to become PHP. So under these circumstances, you have to work around how you're going to apply your logic, your business logic, still using the ORM tool. So the first thing that we worked with was exactly with the second level cache. So we implemented second level cache support because we couldn't purely handle this using database. Now, when I'm talking about not using purely database, I'm talking about using other kinds of storage. So we started using REAC with NoSQL-like key value storage, but it does have Solr capabilities, searching capabilities. So the first thing that we've done is using this as the second level cache, which means we had all the entries also existing inside of the cache storage. Now, whenever we had a situation like this, we did have a secondary place that we could fetch for the information. But we still needed to actually do an update table, for example, which would lock the entire database. So to avoid this kind of problems, we created a tricking script. That's what I would say. So the tricking script was something that we were pointing to one specific database, and all of a sudden, we would start creating and modifying using triggers to another database table that would contain our new database structure. And this would have triggers for update, delete, and every single operation at the top of the existing records. And at the same time, we had another script migrating the data over. So as soon as this script finished, we would have a blocking time, so a scheduled maintenance that would just move from one database table to another, and problem solved. Now, I know that's a naive approach, and unmuted. I unmuted myself. Guys?
That was my fault.
Okay. So I know that's a naive approach of handling a migration of data, but the problem that we have is that whenever you're dealing with the database tables, you are entering a multiple inserts per second situation, which is exactly what we had at that point in time. So we could potentially be offering a stale information until the database migration was over, or we could still keep the system live, which was the case that we had to have, and dealing the migration in the background. So we had the case that we were dealing with a migration of 5 billion rows. So it took us 2 days, 3 days to actually get the data ported over to a completely different structure. And once it was done, we just switched it over, we merged a branch with the entire feature, we refreshed the cache, done. That's how we approach the migration. Next question. I'm going to mute myself.
I don't know, either everyone's shy or they just don't have any questions. Darryle, you got anything? All right.
So for all the people who just got this major doctrine, high-level guru, Obi-Wan Kenobi data dump of information right now, to the point where they can't think of a question to ask you at the moment, but they would like to find a way to contact you later, Welcome to New York. There's sirens in the background. But what is the best way for them to post a question, to reach out to you for some doctrine question or thing they're troubleshooting in their side project or at work? Where should they post a question? What forum? What tweets? What Twitter followers should they follow? Yeah.
Okay, unmute me. Someone needs to mute James. Okay, there you go. So I'm very active online, so you guys can find me on Twitter, Facebook, ERC. I'm online on Freenode and EFNet. So if you guys need to ask me absolutely anything related to Doctrine, we also have ERC channels on Freenode. So it's found Doctrine. We also have the Doctrine-dev. So I'm always there. I'm always around. So if you guys have any kind of questions, you guys can poke me on Twitter. You guys can poke me on the ERC channel, Facebook. That's all good. Like, I'm always online. I never really sleep much. So you guys should be fairly easy to contact me. Now, I've never seen who is actually watching the presentation. So now I'm seeing you around. Hey, guys. So don't be shy. If you guys have any kind of questions for me, feel free to shoot. It doesn't need to be today. I know you guys are like almost 9. You guys are hungry. I heard that there was pizza at Spotify. So
There's a lot of pizza, beer, and whatnot.
Yeah, so if you guys need anything, feel free to shoot me an email. I coded pretty much what's inside of Doctrine 2. TQL is my responsibility. Hydrator is my responsibility. Persisters, which is something that you guys don't manage on a regular basis, is mine. Extra lazy support is mine. Annotations, I coded from beginning to end. So whatever you guys need, shoot me an email. I should be able to reply. So if you guys need to send an email because it's a very lengthy thing and you guys don't want to discuss on ERC or Twitter, you guys can basically just send me an email by first name, last name at gmail.com.